Hey guys, today we're going to be looking at displacement and velocity. So first of all, physics is mainly about motion, and we need to look when we start out at one-dimensional motion. So to begin, we need to understand, well, what is one-dimensional motion? It is really the simplest form of motion. You can think of it as an object is moving in a linear fashion, okay? It's moving in a line. So if you want to think of this train, the train on a linear track, it can only go forwards and backwards. We're not going to think about it moving to the right and moving to the left or anything like that. Linear motion, everything is moving in one dimension. Now later on we're going to get into two dimensions where we may be moving up and to the right at the same time, but for now we're just looking at one-dimensional motion. Now, one thing you need to know is all of motion takes place over an amount of time, okay? Time is always a continuous variable that's going to keep on moving, okay? That's why some people think of time as the fourth dimension. It always continues. And motion also depends on the frame of reference. Now, when you think of a frame of reference, you need to think, well, who is doing the observing? So let's think we're sitting on the earth. Well, if I throw an object up, right now, I can't even catch it, okay? My frame of reference is me, and this ball, right now it's not moving in my frame of reference. I'm holding it still. When I throw it up, it's not moving very fast. I'm not giving it a very fast throw or anything. However, we are moving close to 1,000 miles per hour. If someone was out in space watching all of this happen, they are seeing me and this object not only move 1,000 miles per hour, if we were closer to the equator, but also they're seeing this chapstick take a parabolic path, because not only is it suddenly moving up and down relative to me, it's moving relative to the earth or relative to the observer. So we need to be careful that we pay attention to where our frame of reference is. When we look at motion in physics, we will always be looking at relative to the ground. We won't look at problems where an observer is out in space watching everything happen. It's all going to be relative to the ground. Or you can think of, when you're in a plane. Okay, when you're in a plane, you can get up and walk around and fiddle with things and read. The fact that you're going a huge number of miles per hour, that doesn't affect you. You don't really feel like you're going that fast because you're able to walk around and do all of these, everyday things. So that being said, if someone was on the ground looking at your motion in the plane, they would see that you are moving very, very fast. So motion is all relative. It all depends on our frame of reference. Okay, now let's look at displacement. Displacement is a very easy concept to understand. The word displace is in there, so you can think of, in physical science, when you look at volume, you look at water displacement as a way to find the volume of an object. So displacement is just a change in position. Okay, if an object is at rest, then its position is not changing. That means it has a zero displacement. It's not moving. But as an object travels from one position to another position, the change in that position, the length of that straight line path, would be the displacement. Okay. Now, the length of the actual path would be distance. For example, I'm going to walk around my desk here. Okay, I walked all the way around my desk, ended up at the same spot. So my initial position was here in the seat, my final position was here in the seat, so we would say my displacement is 0. However, the distance that I took is, I would have to measure the length and the width of my desk and actually measure the path that I took. So path of travel here is your distance, and the linear path, like if we could take a string and stretch it from where you start to where you end, that length is your displacement. So in a lot of these problems, we'll be thinking of an object going back and forth. I can take any route I want to get to a final position, but it wouldn't matter. It wouldn't matter if I went straight to that position or if I went zigzag to that position. I would have the same displacement. Okay, here's another example. We have displacement is change in position. So this is the equation. We have delta x. Delta means change. Okay, x is the variable that we use for position. Okay, it's not always going to be on the x-axis. Don't get that confused with like a math class. So delta x equals our final position minus our initial position. Here's an example. We have a football player starts on the 20-yard line and then it moves to the 35-yard line. So the total distance it has covered so far is 15 yards. But then the team gets a 5-yard penalty and the football moves back. What is the displacement of the ball? Well, we started at 20. We went to 35. And then we lost 5, so I ended up at 30. My final position, 30, minus my initial position of 20, gives me a total displacement of 10 yards. Now, let's say that I went, let's say I wanted to know the distance instead of displacement. Well, distance, we have to measure that actual path that you took. So from 20 to 35 yards, that's 15 yards that ball traveled. And then it traveled 5 more, so that's 20 yards. So even though the distance is 20 yards, for displacement, we only care about final minus initial, which is 10 yards. Here's just a picture looking at maybe let's say we have 3 people. 3 people or 2 people, a green person and a red person. They're taking different paths to school. Because they start and end at the same place, they have the exact same displacement. However, they will have different distances. Here we can look at the sign of displacement. Basically, if you are moving to the right, your displacement is positive. It's just like in a math class. We always call up positive and to the right positive. Oh, that's your left. To the right positive. Okay? Up and to the right is always positive. Let's see. So here you can see we're going from about 10 as an initial position to 80. So my displacement is a positive 70. 80 minus 10 is a positive 70 centimeters. Make sure your units are always going to be a unit such as displacement. So that's meters, centimeters, miles, kilometers, inches. Now for physics, we will always use meters. Okay, you're going to be pretty used to converting between meters and centimeters in here. Never use inches, and we only use yards if the problem deems it appropriate, just like that football problem that we just looked at. Look at this positive here. If I'm talking about displacement, I need to make sure I understand whether that displacement is positive or negative, because positives and negatives in physics just tell you about the direction. If we have a negative 60 centimeters, that tells me the ball must have moved left 60 centimeters from where it started. That was its displacement. Just like here, we have negative 15, negative 10, and so on. And if you want to pause and try to work your way through these 3 examples, go ahead. Now, velocity is not the same as speed, just like distance is not the same as displacement. Both of these terms are going to describe how fast something is. Velocity and speed are both rates. Okay, remember, it's motion over time. This is how fast we are changing something over time. Velocity specifically is how fast our displacement is changing. So we're looking at a change in position, that's what displacement is, divided by time. However, speed is distance divided by time. So think of this if you are a runner. Okay, if you are a runner and you run 4 miles around a track and start and end in the same spot, your velocity would be 0. miles per hour because you went 0. Your displacement was 0. You started into the same spot. So 0 divided by any time. Let's say it took you 1 hour. So you're not a runner. You are a solid walker. It took you an hour to make that track loop. Well, then your displacement 0 divided by 1 hour would be 0 miles per hour for your velocity. So a runner doesn't want to use their velocity to understand their motion. In this case, we need to use speed. We need to know, okay, you went 4 laps around the track. So you went 1 mile. That was your distance. Okay, and you did that in 1 hour. So 1 mile divided by 1 hour is 1 mile per hour. So notice velocity is going to have a direction to it. Okay, a positive or negative. Velocity can be positive. If you're moving to the right, you have a positive velocity because you have a positive displacement. If you're moving to the left, you have a negative velocity because you have a negative displacement. Now, if you look at time here, can time ever be negative? Can you ever have a negative 2 seconds? No. So velocity is always going to be the same sign as displacement. Velocity and displacement vectors always will point in the same direction. Now, you just heard me use the term vector. A vector is something where direction is important. So like displacement and velocity, both of those are vectors because we care. Am I moving to the right? Am I moving to the left? However, if I don't really care, if I'm talking about distance, I don't care I don't care that I went to the left. I still need to include that distance. Then that's when we talk about a scalar. A scalar quantity is a quantity that does not need a direction to fully describe the motion. In most cases, we will be looking at velocity, where your positives and your negatives, they definitely matter. Okay? So you'll get used to that as we continue some examples. All right, that's all I have. I hope you guys have a good evening or morning, whenever it is you're watching this video.